I'm Steve Taylor, Associate Director with Allford Hall Monaghan Morris. It's a real privilege to come and talk to fellow concrete nerds, I guess, in a certain way. Very quickly about White Collar Factory and the principles of the concept. It was building on about 25 years of working with Derwent London, and particularly a number of buildings where we were lucky enough to work with them on reinventing these buildings. Old buildings, 100, 150 years old, and converting them into new, modern places of work. And really what that afforded us was a question that then said, what is it about those buildings, what are the characteristics about those buildings that keep making us go back to them? Why are they so special? Why do they convert so well from one use to a different use and potentially back again? And then why don't modern buildings of the 21st century quite do that in the same way? So we went back, did a bit of research work before we even got into the architecture of it, understood some of the characteristics of those buildings. We also looked at some of the past masters, and in particular, Jean Prouvé and Frank Lloyd Wright. Like a lot of things in architecture, some of our ideas aren't new. We're just bringing them to the 21st century and sort of building on them. And for us, it was working with the concepts of Jean Prouvé, taking mass production from fabrication and bringing that into architecture in the sort of 30s and 40s. Frank Lloyd Wright and his work with volume and light, and also collaboration and coordination of services. You know, he put pipework in slabs before we ever thought of it. It leaked because obviously he used metal instead of plastic pipework. But it was building on some of those influences and coming up with an idea about the 5 concepts for white collar, which is really about the characteristics of those old buildings and those past masters. We then took that into a baseline project. So this is irrelevant of site, in a way irrelevant of architecture. This is just about that concept in its rawest sense. It's about creating spaces that are 3.5 metres tall, that are naturally ventilated, naturally lit as much as possible. The idea about on-floor plant. And then we benchmarked that against a cost of about £165 a square foot. So this was a building which was non-site specific, 45 metres square, not very tall, so we're not having to put extra lifts and sprinklers in. There's no basements, but this was our baseline. So taking our concept, developing it in the raw would be this as a model. And obviously there's no architecture on this, there's no site for this. But obviously when we move this as a concept to Old Street Roundabout, Silicon Roundabout, it changes site, it gets less efficient. Cores go taller, they get fatter, you add more floors to win more area, core gets taller again. Each time you make those moves, you're adding another £3, £4, £8 a square foot onto your baseline. But the important thing for us and for Derwent was every time you make those decisions, you refer it back to your baseline, you know why you've done so. So in sort of very similar concept to those warehouse spaces of 100 years ago, which were built in a sort of very lean way, we were sort of trying to do that. And really create space which gives you everything you need, but also the ability to add as you need to develop it. So we then took the concept and we built a prototype. Some of you may have seen this or visited it. This was built on site, on stilts, about 10 metres up in the air. It's about 2,000 square feet. It was fully functional, so we had cold water pipework in the slabs, tall ceilings, exposed surfaces. We ran it for 12 months, we collected the data. We proved, working with our engineers AKT and with Arup, that the system worked and that everything was okay. So based on that, sadly we took it down. Benji wanted it in his back garden, but he ran out of time, so we had to take it down. But really replaced that 2,000 square feet into about 240,000 square feet, over 16 floors in the building that we can see across the road today. So having set up all those principles, really what undermines a lot of it is the concrete, is the structure, the ability to take on the thermal mass. Ordinarily, you wouldn't necessarily build 16 stories in concrete, you know, steel would come to mind. But for us, white collar and the idea of concrete is the fact that it's multifunctional. So of course it gives us our structure, it gives us the idea about facades and a real opportunity for robustness of facades at this kind of gritty end of Old Street. You know, it is a proper urban situation right on the street. We can then use that concrete as a carrier for our cooling as well. So this is all our embedded pipework in there. That is I think that's about the 4th floor of White Collar Factory as it's going up. And of course finish as well, as you are all well versed. You know, the idea about concrete as our final finish. For us, it kind of takes us back to ideas about historic buildings, cathedrals, that idea that it's a natural product, and like stone, concrete can kind of take on the ambience of space and it over time almost take on the sort of richness of how people occupy that space and just get better over time. You know, it's a finish which looks great now, but will also look great in 50 years' time, 100 years' time. So making the concrete, these are some of our scope drawings. I won't go through the whole pack because there's about 600 drawings, but this gives you an indication that the amount of concrete we have in there, the amount of structure, it is a loss of finishes as well. There's an awful lot of it which we have to get right. There's a lot of it on the tenant floors as well. And as Simon said earlier, back in 2006 when we finished Johnson, there was a lot of concrete in the main atrium space. There was some nervousness about it, and how the market has changed. So this space, tenanted floor areas, the red is the exposed concrete. There's a lot of it. There's very little plasterboard in this project. And in a way, that in itself creates those problems which we're now learning on site, of course, working with our contractor Multiplex, because you're sort of throwing away those follow-on trades. So you create your structure. Ordinarily, you'd then cover it up and then get those final finishing trades like joinery, curtain walling and so on, which have much tighter tolerances in concrete. Ordinarily, you'd have a third trade to help close some of those tolerance gaps. We don't have that here. We've kind of exposed a lot of that. So we're sort of learning to deal with that as we go. You predict a lot of it as you can, but this is built by human beings, not robots. So there are things that fall out of your expectation of tolerances, and you have to deal with that. And the concept, I have to say, is kind of robust enough to deal with it. So we have the scope, we have the detail, everything's covered up. You have to then set out light switches and your front doorbell. And you do that from the start, of course. So as soon as the main contractor started, his trade contractor Duns, sadly no longer with us, they've done a fantastic job, has to be said. We worked with them very closely, very early on, to coordinate all of this stuff that ordinarily you'd have to look after later on. So to get there, we need the ingredients. And as you well know, in terms of kind of healthy building, the idea about wellness in office working environment, we set ourselves some targets. We have achieved BREEAM Outstanding. We have achieved LEED Platinum for our cousins over in the States, which is important for tenants like Adobe, for instance. So we've got all of those. They have to be considered. You've got GGBS, cement replacement that needs to come in to achieve some of those targets. And of course, all those ingredients, it's a cliche, but we are making a cake. It's a very big one. You guys know all of this stuff. The stuff I'm particularly interested in as an architect are these two, which will change the colour and the finish of those ingredients. The fine-tuning of a lot of that we can focus on, but of course, it's all yard dependent. I mean, you might be making a cake, but it's on an industrial scale. You know, it comes out of places like this. So anything which goes wrong can go wrong quite quickly. So we therefore have to protect that very early on in our benchmarking of the project. So we look at those ingredients that affect colour, and to get it right, we build mock-ups. And Derwent, you probably are aware, are well versed in making mock-ups for lots of buildings. Now, luckily for us, very luckily for some of us, our mock-up process started in New York. Some people already done mock-ups for us. So Annabella Seldorf did the Zwerner Gallery back in, I think, 2012, exposed concrete on the facade, board marked, beautiful building, very fine, but some of the details lost until you get very close to it. One of our other heroes, Saarinen, in 58 over at Yale for student halls of residence, really the roughness of some of that workmanship gives us a character of that building today, and it actually gets better over time. The trip was well worthwhile. We earned more over here than we did over here. So we took a lot from that trip. We came back, we made lots of samples, played with lots of mixes, played with lots of different mixes for our GGBS and our PFA, narrowed it down. We ended up somewhere between these two medallions. In the process, we thought we'd start looking at the timber in more detail as well, looking at very readily available timber species and how that can affect the look of the board marking. We played with different variations on build-ups of that board marking, and also in the process of mock-ups, you're testing working joints, corner details, and then inevitably with these processes, you end up with a lot of men standing around, hands on hips, and pointing. Spot the architect, they're always pointing. And we made two mock-ups of our two preferred mixes, but then tested all those details, all those working details, with our concrete frame contractor and our main contractor. So we got it right at this stage. So we built two of these. We made a whole load of decisions, keeping detailing very simple, actually. We looked at elaborating on it a bit more, and we didn't feel it worked for us necessarily, so we moved away from that. And of course, that's all fine in sort of small 3-metre cube bits of mock-up. We're building 16 stories of it. The concrete's on the critical path. It's a jump form. How do you repeat that process again and again and make sure it's right? So we've done a lot of detailed work with our friends at Reckley, who, as you well know, create lots of standard profiles, which work to a certain extent, become a sort of wallpaper for repeating. So we tested a lot of that, didn't feel it quite gave us quite what we wanted. They're good in their own right, but we wanted to do something for ourselves. Understanding the process of using timber shuttering, of course, timber absorbs moisture, it makes the concrete, gives it naturally some variation. We don't necessarily have that or that luxury building it over 16 floors. So what we do look to do is form a sort of latex version of it, create our own bespoke mould, but to then also create that sort of variation, we look at board thicknesses as well. And we make a bespoke mould. So this is a 7-metre by 4.5-metre mould made out of our preferred timber, looking at different timber thicknesses to create some depth and relief. And then overall gives us something which we felt is rather special, really quite special. We're not hiding the fact that this is jump form. We have tie holes, we have joints, we have lots of concrete detailing. And of course, really once you've set that process, set that benchmark, you've got to build the thing, you've got to build an awful lot of it, and you've got to maintain that quality. So understanding construction sequence and those methods are really important to us. So understanding how all those elements can be consistently good was important. Understanding how you can get finished walls at the ground floor of a building off a critical path, and some of those soffits as well, get them off a critical path so it allows you time to do something quite special with it. And of course, that in itself can be quite complicated. So you take standard formwork, you line it with our mould, you apply, of course, your tie holes and your reinforcement, you clamp it all together, we pump concrete from underneath. So of course, we've got a floor slab already gone in above this. You take it away, it gives you your first skin of concrete, you're adding waterproofing, you're adding insulation, you're pouring the second skin of concrete up against that directly, again, pumping from the base, in 2 jumps. So this is a 7-metre high jump around the base of our building, so consistency and speed was very important. And in that type of sort of pumped concrete, self-compacting concrete, we get some of these detailing which start to come through, that sort of method of construction. And of course, when you understand that, you can start setting it out. You know it's going to happen, you know you can't hide it, you can start drawing for it. Other things, so jump form, you're sort of whizzing up every 4 to 6 weeks. This jumps up from floor to floor, leaving brackets for those jump jacks as they go up through the core, which ordinarily leave you scars. Some of you are obviously familiar with that. We then design those in to be hidden in raised floor zones. Where some of our floors are double heights, such as our main reception and also our staircases, there's no hiding. Some of those jump form and joints you're going to have to express. So again, we tested those and then tested those in reality on those staircases. Columns, we all know about those. Some lessons we learnt about from our show suite, the prototype, was a bit of a surprise really. I mean, the columns here, we're using a cardboard liner. They came out really shiny. I mean, they were beautiful things like marble effect, completely unintentional. We all loved it. The main contractor said, I'm pleased you like it, but we can't guarantee we'll get it right on every single column because we're as surprised as you are. It's turned out quite so well. So having learnt from that, we set different benchmark for us. So we looked at other buildings like the White Building at Nottingdale, and we looked at different ways of how to form those shutters. So we're taking our reinforcement, we're wrapping it in a GRP liner, we wrap it again with cardboard and formwork straps, you peel it away, and you're left with that single seam running up that column. And again, we allow for some variation in that as well. And of course, as I said, we've got a lot of those in the building. Some of them come out like that, and you're quite surprised for them by that. Over time, it dries out and it ends up like this. So it's also about, I think for us, managing our expectation, managing that of the client, our client, who wants it to look like this straight away, a lot of the time. And for us to kind of say, it's okay, keep the faith, it will dry out, it's going to improve. And like Saarinen, it does get better over time. So the consistency is there on the project, it has to be said. Slabs, we're using standard formwork, as you'd expect. We're not doing any clever setting out of that. But what we are doing, which is clever, is adding, and I'll say, it's clever, but it's not a new idea, is putting pipework in the concrete. So we're pre-bonding the pipework to the first line of reinforcement. The additional rebar goes over the top to help protect that. Concrete is poured, and these poor guys, as you've probably seen, a lot of them walk around in the rain doing a lot of that, trying not to stand on bits of pipe work. The pipe's left under pressure while the concrete's gone in, of course, so that we can maintain for leak detection and so on. These slabs are left out in the weather. Slab edges we need to be particularly careful of for sort of rainwater runoff, so a lot of protection during construction works are important. And of course, a question which a lot of people ask, which I guess is an obvious one, is we don't want it to rain on the inside, so to stop people drilling holes through our pipe work, it's quite a simple thing actually. You just give everyone a drill bit. So the contractor free issues all the drill bits to the trades. They're a bespoke drill bit. You can't go more than 30 mil, so nobody should drill a hole through a pipe work. That then goes into our O&Ms and it gets free issued again to tenants and their fit out contractors as well. And I don't think we've had a single leak, so which is good. Not that I've been told about. This setting out of that slabs, I think architects can get quite precious about setting out of joints. I think I've demonstrated that with some of our earlier scope drawings. But in the slabs, in a way, you know, this building occupies a corner site on Old Street Roundabout. It isn't square. There's a lot of corners and chamfers going on. What we've done simply is just set out from a single point of origin from here, using standard 8x4 foot sheets, run it out. Some of those, you know, they miss column lines. In other projects, we've tried to line those up and sort of driven contractors mad by it. But in a way, we've allowed ourselves to be a bit more relaxed with that. Because really, it creates a sort of blank canvas for those services to be suspended from. So having established our benchmarks and our sort of ingredients and our sort of route map, if you like, and how we worked out how the sort of methods involved in the construction, we looked to benchmark it again against some precedent buildings. So we've talked about this earlier, but this is cathedral finish Angel building, which is a really easy benchmark for us to use. We worked on that again with AKT and, you know, really happy with it. Lots of contractors don't like it as a benchmark because it really is quite a sort of top quality. We then looked at finishes again at the white building, the idea about allowing some of that variation of the slabs and some of that weathering to come through because it is inevitable. And then over at Chobham Academy over at Stratford as well, where you can be quite relaxed about some of the finishing on that concrete as well. So you set some realistic benchmarks, but then importantly you then try and capture all of that knowledge. You know, this was a sort of 9-month process working with the contractor, and you set it all out in a sort of benchmarking report. So it's really about capturing that collaboration between design team and contractor, securing that concrete mix, actually editing all the stuff that didn't work, you know, getting that out in an appendix, getting the construction methodology right and those standards. Quality and workmanship will come from this. You tie in those benchmarks so everyone knows what we're trying to achieve and sort of buy into that. And then also, I think importantly for us, and managing that expectation, is the levels of execution and remediation. Is being quite relaxed about it. It's kind of saying where there's a little bit of honeycombing, that's okay. It's part of the sort of process of concrete as a natural finish. Where there's scars where you in the concrete which you didn't expect, that's also okay. That adds the character. So having set all of that up, I'll run you through a quick update. This is a facade from the building opposite. I'll put it in just because I think it's quite a fairly magnificent view. And of course, behind all of that curtain walling is our concrete. Bits of concrete allowed to come through, like our triangular soffit above our main entrance, so you get a hint of what's to come. The idea about coming into a turbine hall, so this is double height space, the idea about a cafe existing on the raised unit over there. But as Benji said earlier, you come in, you see the concrete straight away. Reception desks are allowed to move around this area, or indeed get taken out entirely, so this becomes a kind of reception turbine hall, not an office reception. We're projecting signage through these sort of things onto the wall, so we're not painting our concrete, we're leaving it really as it is. So all of that stuff can get turned off, and this becomes a kind of fully functional sort of party suite, as well as an office reception. You've seen concrete do these kind of wonderful things in many other buildings, Lasden being one of our favourites. But it really is, it's even after so many years of work on a project, we're surprised, I'm personally surprised how good a lot of it is. You kind of go on, you've been working on it day in, day out for anything up to 8, almost 9 years now, I think, Simon, isn't it? And you still surprise yourself how some of the quality, how daylight can hit concrete, and all that work about worrying about an 18mm bit of timber next to 12mm bit of timber, it was kind of okay. It was sort of worth spending that time and those kind of sleepless nights over it. Some of those lift lobbies, so the tenants as they exit the lifts get to enjoy all of that as well and really become the sort of benchmark for them and what they want to do. Working with precast as well as in situ, so this is our main central stair. This is really as finished, a bit of tidying up to do. Durbar plate as nosings, that's not going anywhere. So it's, it is a building built for a legacy, real legacy. Steelwork dropped into those concrete shafts as well. A lot of those connections just left exposed. And then the idea about those emerging floor plates. The facades here, I know this about concrete, but I can't help myself. Facades here are only 30% glazed, which is part of our heating and cooling strategy. So the idea about the healthy building, that you can open a window, fresh air comes in as well as daylight through these holes in the facade. The ductwork turns itself off, you open a window, you naturally vent that first kind of third perimeter of the building. To do that, the concrete's helping to do our cooling, but to get all of that right, you've got to limit the amount of solar gain we're getting into this building. So this is really facade, structure, architecture, skin, services, all kind of working together, all being on show visually, but all having to be very detailed, coordinated in a very detailed way. So we restrict the amount of solar gain we get into about 30%, but even on a day like this, floor plate, still film on the windows, only contractors' lights turned on, and it's the, I don't know what BCO says about the type of light levels we get in there, but that's a pretty marvellous space to go and want to work in, I think. So it's about challenging all those norms. Finally, I'm not sure, Simon, whether you've seen this, but we're up against this, of course. At the moment, we've got over 400 people working on that site, although a building of that size does swallow them up very quickly. Getting them all not to do this sort of thing, although this is kind of could have been a lot worse, but it's certainly not Banksy. But it's trying to control that on site. And then, of course, as we go through the whole snagging process, trying to control certain elements that we feel we should come back and have another look at, some of which will die down over time, some of which we can do something about now. But just being very open with the client and the contractor in that process. And that's me. I think I've talked long enough. I'll hand over to Rob.